Okay, today we're moving on to concept 10, which is equations and inequalities from real-world situations. So to start with, we know that equations always have to have the equal sign, and inequalities should have any one of these four signs. So we've got the less than, the greater than, the less than or equal to, that's with a line underneath it, and then the greater than or equal to sign. Okay, now here's our first example. The area of a rectangle is its length multiplied by its width. So what we want to do here is we want to figure out, well, do we need to write an inequality or an equation? So one word that I always look for is the word is. Now the word is tells us, in this problem anyway, that it's going to be an equation. So if you take the area of a rectangle, is, or equals, its length multiplied by its width, we just now need to be able to pick out some variables here. So if you take a look at this problem, we have some variables. Here's one of them, the area. And, I mean, we see the word rectangle, but that's not really a variable. The rectangle is what it is, but it does have a length, and it does have a width. So we need to be able to take these three and change them into a letter that we can use to represent them, and then we can make an equation from that. So we say that the area equals the length times multiplied by the width. Okay, so that's how we could build that equation for this problem. Okay, this is example 2 now, and so we have the problem, a space shuttle must reach a speed of at least 17,500 miles per hour to stay in orbit around the Earth. Now in this one I don't see the word is, which is a good indication, like in the last example, that it's going to be an equation. What I do see though is the word at least. So the word at least, we learned in concept 4, means greater than or equal to. So instead of writing an equal sign first, I'm going to use that sign, greater than or equal to. And then I've got a number, 17,500, that's got to be in my inequality someplace. And then we have a variable. Okay, so we're talking about speed here. So for this problem, we have that speed has to be at least 17,500 miles per hour in order for that space shuttle to stay in orbit. So I'm going to use S for speed. And I'm going to fill in my value with 17,500. So this becomes my inequality for this situation. The speed has got to be at least 17,500. Now, to test it out, something that's bigger than 17,000 would be 20,000. And this, in fact, would keep that space shuttle in orbit if it was going 20,000 miles per hour, so that makes that sentence true. If we want to cite a non-example, what if we said 15,000? What if it was only traveling 15,000 miles per hour, which is really fast, but in this case, it's not going to keep it in orbit. If we did this, then that's not a true statement. So that's a non-example right here. That doesn't work. So anything that's greater than, it has to be greater than or equal to 17,500 in order for this to be the inequality we want. Okay, we're ready for you to try the first practice problem. So this is number 1 in your SSS packet. So it says to write equations or inequalities to show these situations. So in this one, the area of a triangle is half of its base multiplied by its height. So it's your turn to practice now. So I want you to try to see if you can build either the equation or the inequality. So pause the video now. Did you get an answer of A equals 1/2 times the base times the height? In order to get this solution of area equals half times base times height, the way that I did, I looked for, like we said before, a keyword is. That's going to tell us I'm going to have an equal sign. All right, and then I look for different keywords here. Area is one of them, and you guys are probably used to seeing this as an equation maybe back in elementary school, because you know that you have the area is equal to half of its base multiplied by, that makes it easy, its height. So if you take all those keywords, there's a lot of them here, but if it's the area and it is half of your base, half of, remember this word of always means multiply in math. So half of the base times the height. So that's how I solve that one. Okay, now it's time for our second practice problem. And this one involves Billy going to the store and he's got $90 and he wants to purchase a leather jacket for $45, a hat for $10, and the rest on jeans. Now it says that each pair of jeans costs $35, so they want us to write an inequality for the number of jeans that he can purchase. So I want you to take some time right now to see if you can set this up. And remember, we are looking for the inequality for the number of jeans that he can purchase. So you should have a variable, and you should have a number of jeans that you believe would fit into that solution. Alright, so let's see how we did setting this up. This is a little more challenging. Billy has $90, so regardless if it's an inequality or an equation, I like to put down what my total is going to be. So it can't be more than $90. It could be exactly $90 that he could spend. So I can't put an equal sign for that. I know that he can spend less than or equal to $90. And it's okay if he's under, but he just can't be over $90. So that's why I chose that sign. And some of the other things that he wants to purchase here, besides the jeans, are $45 for the jacket and $10. I need to add that, $10 for the hat, and then the rest on jeans. So I'm going to use, and it doesn't really matter which variable you use, I'm going to use J for the jeans. You could use N for the number of jeans if you like. So when I want to solve this, I want to figure out, well, how much money can Billy actually spend on jeans in order for this to be a true inequality here. So what I'm going to do is I'm going to combine my like terms. We talked about like terms in one of the earlier concepts. So if I have $45 and I can add $10, that's $55. Plus, now I can't really do anything with J. There's nothing to combine. There's no like term with that. And then I can leave my inequality sign is less than or equal to 90. And then I know that 55 plus something is either less than 90 or it's equal to 90. So to solve this, I always like to do the opposite of this, which you'll learn a little bit later here when we solve equations on concept 11. But I like to eliminate the 55s then and just be left with J is less than or equal to, in this case, 35. Okay? So, but be careful, it's not saying how much money. So it says, what's the number of jeans? So in this case, even though this is an inequality that's left, we could also say that the number of jeans he could buy, since we know that one pair of jeans, I should say, is $35. So he can buy either, in order to make this inequality true, he can either buy one pair of jeans or he can buy less than one. So I said J is equal to or less than 1.